Based on what I'm looking at on Canvas, when I see some of the submitted assignments that some of you have already completed, it looks like you have, some of you, a reasonable idea of what I'm asking you in numbers 6 through 8 of the Digging Deeper assignment, but you're not answering as specific as you need to. Your answers need to look like what this video is talking you through. But if you went through the appropriate process and you watched this video before trying to do the problems and you looked at this stuff that they said and it made no sense to you, then that's what I'm making this video for, to hopefully help it make more sense to you. So, problem is asking which pairs of figures in the grid are congruent. First and foremost, remember what that means. That means, for our purposes, that I can take one figure and map it onto the other, meaning I can do a rigid transformation, a translation, a reflection, a rotation, or a combination thereof to get one to the other. That's what it means for two things to be congruent. So let's start simple. Let's start with the easiest diagram in the figure, which would be the segments. That's segment PQ and segment HG. If I take segment HG and I get my handy dandy marker over here, if I trace HG, and it's not perfect, but I think you get the idea, you can see that yes, I can in fact take this figure and move it over somehow so that it will map onto PQ. And now I just need to specifically indicate how. So, well, before I go deleting this, look at what I did. I moved it. I didn't turn it. I didn't flip it. I just turned it. That's a translation. So we know that we're going to be writing a translation rule. So the translation using some rule of segment HG gave me segment PQ. So what did I have to do? How did I have to slide this? Whoa, that's not what I meant to do. How did I slide this red segment from HG till it landed to PQ? Well, I would hope that you'd realize and remember that horizontal shift comes first, so how many spaces am I having to move it over? I'm moving left, notice, which is a negative direction, and since I moved it 2 spaces, I'm writing down -2 for my horizontal shift. And then, how far am I moving it vertically? Well, I'm moving it up. So hopefully you realize that's a positive direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And since translation using this rule of this segment yielded this segment, I can say that HG G is congruent to PQ. That's the first one. Now I'll get rid of this red segment so it doesn't distract us from other things we're going to do. The next most complicated figure in the diagram is the pair of triangles. So once again, is there something that I can do to one triangle so that it will yield the other triangle? And what I'm doing on my screen when I'm kind of clicking and dragging things around, that's what you can do using your tracing paper. So I'm tracing this triangle so that I can determine whether or not I can take this triangle and map it onto this triangle. Well, obviously it's not going to happen just by sliding it over. It's not going to happen in a translation, but perhaps if I do a rotation of some sort, if I could manage to use my computer properly, hopefully you realize that some form of rotation is what's going to yield us getting this triangle over to here. Okay? As of right now, the easiest rotations that we have been doing and the ones that you will do most of the time are around the origin, this point here. Remember that I have shown you that, let me move this out of the way for what I'm going to do. The easiest way to determine where something is going to land when you're rotating something around the origin is to take your piece of paper and physically rotate it however many degrees you're trying to turn it. And if you're looking, you'll already see kind of where I'm going with this. When I rotate my paper, so to speak, 180 degrees around the origin, this was, let me show you again. Here's triangle DEF. And when I rotate it 180 degrees around the origin, well, look at that. It is exactly where that triangle is. Now you want to make sure when you write the sentence down that you're paying attention to the order in which you're writing things, but hopefully you can see from the figure on the left to the figure on the right, all I've done is a 180-degree rotation around the origin. So how do we write that? We write a lowercase r. Please remember to be careful and write lowercase r's to represent rotations. Okay, so this is a rotation, and I just wrote that wrong. Of 180 degrees around the origin of my original triangle. That is an ugly triangle. Let's try that again. It's a little better. D, E, F. That's an F. And it yielded, and again, be really, really careful about putting things in order. And this is what I mean by that. Look at where D is down here. Notice where it is in this triangle. It's L. So I want to make sure that L is my first letter here. Whoa. L. And then look at where E is. Find its corresponding point. It is M. And then, of course, N. And once again, because, let me move this out of the way, because I was able to show a transformation in which this triangle mapped onto this triangle, that means that triangle, whoops, D, E, F, can't make, is congruent to triangle L, M, N. Finally, we have these two trapezoids. And once again, what you want to do with your tracing paper to determine whether you even need to write a rule, do this in red, is start with tracing. Oh my goodness, that was sloppy. No, get out of there. My pen back. Thank you. I keep hitting buttons on my stylus. Forgive me. Oh my gosh, what was that? Okay, that just went all crazy. Oh, fiddle-dee. Edit, redo writing. Okay. Okay, let's try this again. Okay, now it's behaving. And forgive me if it's a tiny bit off. So what we're checking is, can I take this trapezoid and map it onto that one? And as you can see, it's not going to happen with just a translation. And I would hope that you'd realize it's not going to happen with a rotation. But can I do some sort of flip that will allow this to happen? And yes, there is. So hopefully when you saw the manner in which I flipped that, you saw that I was clicking left to right. That means I have to do my reflection over a vertical line. Now, I don't know about you, but my favorite vertical line is the y-axis. And look at that. This figure is touching the y-axis. So maybe it would be really convenient if before I do my reflection, I bring this oh my goodness. I bring this guy up here over to the y-axis so that then I'm just flipping it over the y-axis and it'll land on x, w, z, y. Okay, so think about what I just said. I want my trapezoid to behave. I want to move this, it's a translation, this to here. Okay, so I'm going to start with the translation. If you recall my very heartfelt apology the other day, because I'm going to be doing multiple things, you have to be writing these backwards. Here's what I mean by that. So I'm going to do something to trapezoid A, B, C, J. Okay, so this is going to need a little bit more space. A, B, C, J. I'm going to be doing a couple of things to it. The first thing I'm going to do to it is a translation. I need to figure out what rule I need to use in order to, as I said earlier, move this Come on. There we go. To here. Well, remember horizontal gets written down first. Hopefully you see that I'm moving one space to the right. And from there, I'm moving 1, 2, 3, 4, 5 spaces up. So in my translation rule, I write 1, comma, 5. And I'm already starting to run out of space here. So I'm just going to bring all this over a little bit. Because like I said, I'm going to be doing a composition of transformations. And the next thing that we're going to do is a reflection. And we're reflecting over the y-axis. That's indicated with a capital R. And when I reflect this, let me clone it first. Clone. Okay. When I take this and flip it and reflect it over the y-axis, it will land at my other figure. And again, you want to be really careful about the order in which you name these letters. I know it may not seem important, but it's tremendously important that you name these things in order of their corresponding parts. So this transformation, this composition of transformations yielded, well, where did A go after I moved it? It came here. And then when I reflected it over, where did it land? It landed at W. So W needs to be the first letter I write. So W. And then same thought process. Where did B go? Well, it was here, and then I reflected it over, and it landed at X. So X needs to be my next number. And once you've got 2, you kind of know where the rest of them are going. So WX and then YZ. And because I could do this congruence transformation, this series of congruence transformations to A, B, C, J in order to get W, X, Y, Z, that means that A, B, C, J is congruent to W, X, Y, Z. And now come back and look at what they had said. Now they went in a different order, but they're saying the exact same things. They did for their trapezoids, they did the reflection and the translation in opposite order. Does that make us wrong? No. As I said before, there's infinite correct answers. You could reflect things over all kinds of different lines and translate them all kinds of different ways and still end up in the same place at the end. But by no means could you have done a rotation here. You had to do a reflection, and that's the main thing that you want to be looking for, is the relationships between the before and the after. So I hope that if this was gibberish for you, hopefully this may have cleared some of that up.